Okay, today we're going to cover solving log equations, and it's really not going to be much different. We just have to use some of the properties that we've learned. So we're going to go straight to some examples of how to solve these log equations. We'll start with a pretty easy one, like log base 8 of x minus 6 plus log base 8 of x plus 6 equals 2. Now these are equations, which means we're now thinking not just our log properties, we're also thinking algebraically. All right, so we have to use a lot of those skills we've learned this year. The first thing we want to do is condense, okay, which is the last thing we did. We need to condense this thing before we start solving it. So we're going to bring these two expressions together the way we learned, which is log base 8 of x minus 6 times x plus 6 equals 2. So we just condensed the expression first, and I think now you can see that this is a difference of two squares. So this is log base 8 of x squared minus 36 equals 2. And now we're just going to do the switcheroo. All right, so we're going to remember that 8 squared equals x squared minus 36. Now from this point on, we don't have to think about logarithms anymore, except for one little thing I'll tell you at the end, but it's pretty minor. Okay, we're not going to worry. Everything else is just algebra. So if I wanted to solve this thing, I have 64 equals x squared minus 36. If it were me, I would do extracting the square, which, if you remember, that just means we get the x squared by itself. So I have 100 equals x squared. Take the square root of both sides, and I get that x equals plus or minus 10. But wait, before we say that is my answer, we need to go backwards for a minute and remember something about the graphs of the parent log function. Okay, there's the graph of the parent log function. What's the domain of this? Good, 0 to infinity, and we don't include the 0. 0 to infinity. So in other words, we cannot take the log of a negative number. All right? So when you get this answer down here, you actually need to at least mentally check it in the original expression to see if you get the log of a negative number anyplace. If I put 10 in, I'm okay, aren't I? Right? 10 minus 6 is 4, and 10 plus 6 is 16. That's okay. But what if I put in negative 10? Don't I get the log of a negative number? So that means that my answer is not plus or minus 10. It's only the positive 10. So x equals only positive 10. So at least mentally, you need to check your answer back in the original equation to see if you're getting the log of a negative number. All right? Number 2. Log base 10 of x cubed minus 1 minus log base 10 of x squared plus x plus 1 equals 1. Well, we need to condense again, only this time there's a minus sign up there, so it's going to be a quotient. So I'm going to have log base 10 of x cubed minus 1 over x squared plus x plus 1 equals 1. Now, this problem can become incredibly hard unless you remember something we learned earlier in the year. So we probably need to come over to Rivendell somewhere. and recall something. Earlier in the year, I told you how to factor the difference of two cubes. If I have a cubed minus b cubed, there's a nice little formula that will factor that. It's a minus b, right, times a squared plus ab plus b squared. Okay, we learned that in the fall, but you're probably a little bit rusty with that formula. And it's actually going to be the saving grace on this problem. It's going to keep us from having a lot of pain. All right? Now, how does this formula change, by the way, if this is a plus? Remember? This one becomes a plus, and that one becomes a minus. Everything else is the same. Okay? Just in case you run into that situation. So if I know this, I can factor that numerator, log base 10, into x minus 1 times x squared plus 1x plus 1, all over the denominator. So why is that so important? Do you see? I can get out the slasher. And now, oh my goodness, does it look better? Now I have log base 10 of just x minus 1 equals 1. And I can do the switcheroo. 10 to the first equals x minus 1. So x equals 11. Okay? Keep on moving here. Now, we need to review, this was a property that I mentioned real briefly before we do the next one, number 3. Remember the one-to-one property? It says if I have the log of m equals the log of n, what's true? If I have this, then what do I know is true? Then m equals n. M, why did I put an E? I guess because I was thinking equals. Okay. M equals n. Okay? So, why is that important? Well, because of this problem. Log base 3 of 2x minus log base 3 of x plus 5 equals 0. Get myself some room here. Now, if you try to condense this one, I think you're going to make it hard on yourself. You always want to be looking for this one-to-one situation because, boy, it's nice to have it in one-to-one, then you just drop the logs and get going. What I can do here is I can add this whole log expression to both sides, like that. And if I add it to both sides, then I have the one-to-one property. Now I'm going to have log base 3 of 2x equals log base 3 of x plus 5. Now I have the one-to-one property. I have the log of something equals the log of something, so I can just drop the logs. Now I have 2x equals x plus 5, and it's a very simple algebra equation. Subtract x, x equals 5. Okay. Of course, these can become more complicated. We better do one of those. Like log base 2 of x plus log base 2 of 2x minus 12 equals 5. Now, on this problem, if you try to get the one-to-one situation, you're going to fail. Do you see why? See this little 5 right here? if I try to subtract this from both sides, I'm going to have 5 minus the log of something. So you can't do the one-to-one property on this one. All right? So you may as well just forget that method. And instead of doing the one-to-one property, we need to just try to condense. Log base 2 of x times 2x minus 12 equals 5. So you have to pay attention. Sometimes you can do the one-to-one property, sometimes you can't. Now I can do the switcheroo, and I have 2 to the 5th equals x times 2x minus 12. Now let's make sure we don't go into some bad algebra here. 2 to the 5th is, let's see, 2 cubed is 8, 16, it's 32. You have to do distributive property here. All right? You cannot set this thing, you can't split this up and set it equal to 32. You can't do that. So we have to do distributive properties. So this is 2x squared minus 12x. We're going to have to treat this as a quadratic. All right? So subtract 32 from both sides. So I have it set equal to 0. 0 equals 2x squared minus 12x minus 32. Now if I was going to solve that problem, I would divide everything by 2 first. Make my life easier. So if I divide by 2, divide all the terms by 2, I have 0 equals x squared minus 6x minus 16. And that'll be a heck of a lot easier to factor. I'm just going to do backwards FOIL since it's pretty easy. That's going to be negative 8 and positive 2. And we split it up. X minus 8 equals 0, so x equals 8. And x equals negative 2. But wait, is there one of those that does not work? Which one does not work? The negative 2 does not work because I cannot take the log of a negative number. So it's only x equals 8. And we are going to stop there for today.